Is it live again? I can see myself on Twitch. Good, one moment. Relax. Not good. Oh, I will check my speed test. In the meantime, you can see that this is the part I already analyzed. Should I go through it again, or did you catch this? Basically, I was explaining this as the connection went down. The root number is a number such that it is formed by adding up the digits 9 plus 9 plus 9, for example, down to 27, and this digits again, and so on, repeatedly, until the number has only one digit, in this case 9. I name this the root number. This part is important. At each step, the number is divisible by 3 without remainder if and only if the original number is divisible by 3. Or let's say any of those is divisible by 3. Actually, it should be true that after one step for example the remainder is the same after one step and in the next step and so on. So in other words, what we are trying to say is that once we sum the digits, the remainder after division by 3 is preserved. We have a number n. We sum its digits, we add up all digits, and this root over 3. So in other words, a remainder after division by 3 is equivalent to this. How do I type check? Good question. I open the terminal. Actually, I have a task. Agda type check. Executing error, you see? It's 99. Alt click. There is a parse error. Like this. This is my compiler. I mean type checker. And I close this window and I see there is an error. Type error. I don't really use Atom. I prefer VS Code. Do I have Atom even installed? No. Let's try. You see, it is not. It can't even install. Why is that? Because I have npm install apm installed globally like this. Atom package viewer. Npm install ng apm, and this installation conflicts with the native pacman for, you know, Arch Linux. So I have in the file system apm conflict for npm and apm, although I could say install atom, ignore apm, ignore npm. No, it does nothing. I'm not sure. I was trying to install with pacman. For some reason, npm is crashing for me. No idea. It says I'm using npm that is incompatible. Anyway, speed test is done. My upload is fine. One moment. npm install. No. npm.js. Yes, you can install, because it is basically a JavaScript. No, that's not an editor. No, it's an electron. You can, however, install the Atom package manager with npm, just that, and nothing else. because its package manager for plugins is basically a JavaScript command line thing. That's it. First, Atom cannot install for me, and second, I like VS Code better because it looks better and I think works better. I guess that's reason enough. I will just share one moment. He's not even online. What? Okay. And what's next? Back to the program, okay? My internet connection is dying sometimes. Back to the program. This is an inductive step. Given a proof of, we can say this, then we can say this. Modulo 3 is equivalent to taking the root number of n and taking it modulo 3. This is one step. This is steps all the way. This is done all the way by summing digits recursively, one sum and the other. Yes, that's pretty good. I have no idea who joined. I sent this link to my brother and some friends. That number doesn't count, the number of viewers doesn't count me, right? I mean, I guess I don't have the stream open right now. I'm not watching myself, I'm not sure even if that counts in that case. Right, back to the program. I shouldn't get distracted. That's basically what I said in a minute ago. This is one step, and the number stays divisible by 3 with the same remainder, no matter how many steps you apply. I know. Somebody joined and left quickly. I never had more either. I mean, it's second time almost the first stream which works. I couldn't stream yesterday. I was at work and still a bit tired from this, so I planned to not to stream too long today. Further, on Thursday I had to run off pretty soon. I was streaming on Friday, I guess. I was starting work very soon, so I did this just to set up. I will improve this setup for streaming again with a better desk. I will try to get not only a desk but also this direct connection to the camera. Next, I will stream tomorrow and on Tuesday, probably in the evening, because then a maximum number of people can reach me. Oh, somebody left the stream. And I'm planning to stream for several days, each week, maybe. We will see how difficult is this really, because it's going fine so far. Anything else? Okay, I have a total of maybe 5 projects. One is this course PLFA we did. Next, is parsing, which I did like 2 years ago, and you see this is still waiting for improvement. I have this on GitHub. Next, I will be doing this Agda thing I'm doing right now, and also an early parser engine. Work in progress. It's pretty complete. 12 issues recorded. I have an idea for a project that I could stream and could be very promising. It's that I would do this parser from zero, ground up, with while explaining elementary ideas from parsing. I would start with the recognizer, perhaps without the forest at first. So half would be thrown out from the ground up version, and also the ground up version would be simplified so that it's easier to understand, although you know the version that is more advanced is also simpler because of some optimization tricks that were done to minimize the amount of code, to simplify the steps taken to recognize things. By encoding grammars in a much simpler way. Okay. You know, there were some issues with the original version of this everything, early algorithm. It was very basic in the 50s. Then it was improved 20 years ago, more or less. But still, I found several networks based on the work of Jeffrey Kegler, several ways to make it even better, I hope. As you can see, it's 460 lines total, with short lines and many comments. And this is basically the entirety of the parser, specifically the recognizer part, which is like half of 13,000 lines in Jeffrey Kegler's work, which is, well, his work is amazing, but he did it in C, and without the hindsight that we have now once his work is done or almost done. What am I hoping to do with this parsing thing? First, I hope to introduce people to elementary ideas from parsing. Second, I would like to introduce people to Rust itself, which is a neat programming language. Third, I would like to actually improve and get some contributors to my project. At least people who could read this, you know. Fourth, so that I could understand this parser better myself, because some parts are still escaping me, and also I forgot lots of things from like 2 years ago when I was doing this. As you can see, the history in this file is May and June 2016. What's next? This is not the only package in this, because what I showed you right now was GRE, which is the engine, the main number crunching thing, data crunching and number crunch, which is running and runtime for a parser. But there's also the part that goes at compile time, because this is a parser generator, so it makes this data crunching thing that runs at runtime. This is the difference between compile time and runtime. Further, as you can see, we have arrows, so the GRE itself uses two packages I wrote, although Panini, which is the generator, uses CFG file more extensively, and GRE is mostly using bit matrix more extensively, because it's important in the recognizer. You know, bit matrix. This is a little library for matrices where in every row there is this bit vector, which means that in every row and every column there are just bits, 0 or 1. You can slice them into like sub-matrices or sub-vectors, of course, and the only tricky thing in this entire library, beyond getting views of parts of matrices, is this transitive closure, which uses the Warshall algorithm. What is a transitive closure? You can find it on internet. Or rather by looking for it's for relation. It has 3 nested loops for rows and columns. You go one way once and the other way twice. I'm sure there was a good tutorial like this on a graph with edges. We don't have edges because we have bits. We don't have a graph because we have it in form of a matrix. Okay. Agda. I just went too far down this 1 minute. Just 1 minute. I went too far into the deep details of this thing, but I explained bit matrix, explained CFG, not yet, but CFG is for grammars, GRD is an engine, and NI is a parser generator. It's split into those little things, regular expressions. I just saw your message. What's next? Do you want Agda? One more thing. I could on a Sunday on the stream do something for the Rust programming language as a compiler thing. That's it. What's next? For Agda, we have this. We'll have PLFA and we have physics. In here, I have some ideas written down and some things that are not yet type checked. What would we do in here? I don't have the strength to do this today, unfortunately, but this is not important. We would one day define physical reference frames and other concepts in physics, such as points, that is events in a physical plane in space-time. We could have delta t, delta space. we could have distances in space-time. We could differentiate between inertial reference frames and non-inertial reference frames. It's all for physics, and I'm hoping to formalize bits of physics in Agda. Why? Well, no, I'm not sure why. Whether it could be useful or not. For sure, it could teach me physics in a natural way. For example, I had no idea, it wasn't immediately clear for me that a reference frame is not inertial in and of itself, but rather inertiality is an equivalence relation for two frames, so that either frame is inertial with respect to the other. What that means is that that either frame is not accelerating with respect to points of the other, but rather the frame is maybe has velocity, so it's moving in respect, but not accelerating at all. Or maybe it's static, in which case it is the same as the other reference frame. Actually, we could formalize this idea by saying that, let's say, if we have that for all reference frames, it's true that it follows that it's true that if these reference frames is no, that's not true. For each reference frame that is possible, it is true that the frame is inertial with respect to itself, that is reflective. And further, we have actually the definition of inertiality of frame in physics, which says that for two reference frames of F and G, named F and G, we could have something that could take some matrix and return and this could represent a rotation. Actually, no. An inertial frame is where there is velocity, so that given how do we do this? Given a vector, which is a velocity, we say that this reference frame I guess like this. But what would be in the reference frame itself? No idea. By the way, how is it done? Do all ADTs such as this actually have constructors? Is there a yes, there are predicates, but we have to have some information as to why this predicate is for this. What would be in a reference frame itself? A reference frame could be a point of starting point and end point, like two endpoints. And we would go from one point in space-time to the other point. And, well, would it be a straight line? No. It would be like frame of reference. The most important thing is that n plus 1 reference points, so in this case, how many? 5? 5 reference points are sufficient to define a reference frame. But that is only at one point in time. So it's like you have 3D editors and you have this coordinate system. Exactly. You have 1 point and 3 more points, which is what Wikipedia is talking about when saying n plus 1 reference points. Unless the reference point is in movement with respect to some other reference frame, where that movement could be described by, I don't know, matrices. For sure, a velocity detector like I did in here. So it's not enough to just say 2 points, but instead you would have like this. Oh, I have an idea. There is an idea. I guess you would have unit and movement. Like, I don't know. I guess translation of a coordinate system given a reference. Basically, we would let's say move this over here or just like this here is done, we could move this point by y here and x here and rotate it. Also rotation in 3D. Oh good. Change from one Cartesian 3D coordinate system. One more. Change from one coordinate system in translation and rotation. Exactly. Somebody is okay, zainwestuję from coordinate system to another old coordinate new. So coordinate change. Given a reference frame, we change these coordinates by getting a matrix of 4 and by 4, 4 by 4 of rationals, I guess. Is that just for rotation? Yes. Although for translation, I suppose this column and this row would be something else. And as far as I can remember, a 4 by 4 matrix is enough for a change of Anyway, the details are not as important, but the main point is that given such a matrix, we change coordinates and get a new reference frame from the unit reference frame. For example, or some other. We could say make our frame unit. The unit reference frame is just there because we need to start from somewhere. For example, we need some starting point. No, not this. We need to start like at this point where we need some reference point. Let's say the center of the Big Bang EU, and we need some point, some measure, some agreed on measure of 1 unit of time further in time, and on this measure everything would be based. So we have limit, and we have and we can change coordinates, change them again, and for some x and y get a new reference frame. Next, given a reference frame, we could move in some direction by, let's say, some velocity, which is a rational number in some units of measure, and we get a reference frame. Although I would say that the velocity can have derivatives. It could be a function from time to velocity at that point in time. Alternatively, we could do away with this and make it a number, or rather a list of numbers which would be like the first number would be like speed, the next would be acceleration, the next would be the third derivative of position, and the next would be actual weight. We could also specify movement as not velocity but rather position, from rational to a point, which is our point in space-time. Although I don't like this, because then we have no idea if this position is constrained by locality. That means whether our movement is happening faster than the speed of light even. So one way is to get velocity, and another way is to get a list of derivatives of velocity. And of course get a vector in which direction this speed is going on. Or rather, we could, this is one case, we could also make this a list of vectors and get a reference frame. Next, we could have angular speed, angular velocity. Given a reference frame, it could be rotating, like, let's say there is this reference frame that is the Earth, and also there is this, there is this reference frame which is in the middle of which encompasses Earth, like in the center of Earth, and is rotating in accordance to Sun's rotation. And there is this reference frame which is on the surface of Earth, like you experience it. So in one case I said it would be first case could be coordinate change from Sun's position to to F's position from sun's position, we've given a reference for frame for the sun, and in the next case we would have the above, but with angular equal Earth's rotation. And those reference frame would be non-inertial. So this gets us a non-inertial reference frame. With respect to the other, angular velocity is, what is angular velocity? It could be an angle. Actually, yes, it would be an angle, a direction, actually two angles, a direction and a speed. Or it could be a vector on the surface, what is it actually in physics? I mean, we could have this vector to describe rotation. Okay, we would have axis and frequency. Usually represented in angle. In 3 dimensions is a pseudo vector, exactly. Oh, I get it. I get it. Right hand rule, I kind of remember. So what we would have, we would have a point on the surface, not exactly a vector, but just the end of the, wait, yes, vector. Because there is some point we need to specify the center of rotation as well. And then, is that it? Yes. And we'll get a reference frame. Measure rate of rotation, we need to have our vectors with some unit of measure. What's next? We need to specify angular acceleration, I guess, with perhaps one origin and multiple could be with one vector. And for the next argument, it would be a list of speeds. Actually, no, not speeds, but higher derivatives of angular position, I guess. Is that even a thing? Derivatives of speed, angular speed could work as well, or angular velocity. Yes, of angular speed. And what's next? Is that all? Perhaps. What's next? We have inertia. inertial reference frame. Actually, I have this new ideas here. Unit would be inertia. Unit is inertia with respect to itself. Same. Given a frame, this is obvious. Reference frame, we would have that. F is inertia with respect to F. And coordinate change. Given what we have in here. Yes, coordinate change like this. One set of coordinates and the other set of coordinates give us that. It's inertia to have like a reference frame that is or just one set. Given two reference frames. This is not needed right now. Inertia. It's inertia that F. It's true that F is inertia with respect to. That's right. Coordinate change with G and coordinate arguments and movement. For velocity, given two frames, for certain velocity, it's true that F is inertia with respect to a moving reference frame with G and this derivations. That's it. Okay. And we say that inertiality relation is reflective. That is, for a reference frame, it's inertial. In other words, we proved it by saying that we would have to prove that two reference frames, no matter what they are, wait. I guess this is enough. I will need to think about this some more. I might put strong ending in here. But I'm hoping to do this, but not only this, also I would do this special relativity theory plus some principles and quantum mechanics, that is uncertainty, and quantum mechanics from first principles. Specifically based on this post on a blog by Scott Aronson. Not this. Who was this? Anyway, from elementary ideas we could get quantum mechanics, I suppose. Next, this would be it. Quantum mechanics plus this special relativity. In those files there is just nothing. Some units in Agda which are, well, I do not know yet how to write them down. Nothing here. Some ideas, some notes, but at least we have something for reference frame, which is a lot better than just like 2 points, which do not make sense, because our reference frame is at least this change of coordinates with, which gives us actually those n+1 Wikipedia talked before. We have unit reference frame, and we get a new one by translation and rotation with a matrix. That's it. What's next? We've been doing this for actually a lot, an entire hour, maybe longer. What could I show you next? Freeman, are you there? No, Freeman is offline. Everybody is offline. Everybody left right now. I could show you a little something of what might we be doing next time, if not Agda. We might be getting sort of this grammar setup. We might be moving parts of this. Comment. We might be moving parts of this from this file to another repository in order to refactor this code a bit, because some parts of this file are generic, like, you know, this is very useful for making the grammar. This is actually how you make it when you use the engine, and this could be useful for other parsers of the array kind, not just this specific engine. So it's pretty clear that I will just move this for a library which could be useful for more than one array parser, not just mine. One more thing, I could formalize this library and also my engine in Agda, which would be useful in the sense that it could uncover any bugs, not all bugs, but the most important bugs there could be, and it could serve as a learning aid. It could show people proof that enough proof that the engine is good. It could serve as something like a technical paper on this engine. Actually, at least some alternative to writing down a technical paper on the technical aspects of this. What's next? So we take this, maybe this, for sure this and this, maybe still this, and move it, or create new directory named maybe array, I don't know. Or some other name, and maybe mirror the file structure that is already in here, naming grammar, history, just in a subfolder, or this code could live, and it would be better, I guess. Would better reflect the actual size of the parser engine, which is, well, that could be an interesting piece of data, because when I go to source and go to journey, how do I count the number of lines? Count this, okay. It's currently at 3,800 lines, which is not much. 3,000 lines. The entire engine which is already functional and optimal, or not perfectly optimal, but it might get close someday. I'm sure it's shorter than MARPA, and also I believe, at least suspecting, that it's also faster than MARPA, much faster. Not sure how much, but it needs lots of work still. That's it. And we will do this work perhaps 15 hours every week, something like that. I'm hoping to stream everything that is happening with this project. Okay. What's next? There are some interesting projects on the internals of Rust going on right now. Perhaps I could talk about this next time. Lots of things to do as side projects. I could translate this library to some other languages. That's it for now. I will be just ending this stream right now. Goodbye. It was quite productive. I went through all the projects. I explained some of Division by 3. I explained what we would be doing next time. Even had an idea on how to make a reference framework in Agda for physical calculations. That's it. Goodbye. Okay.